All right, in this section, I'm going to go into a little bit more detail about the problems people run into when they adopt Istio, why we built our products and the solutions that we bring to the market. In the intro section, we saw that service mesh is implemented by deploying proxies and sidecars alongside each application instance. We had been working for about a year, over a year, on how can we improve that model? How can we make it so that you don't have to deploy a sidecar? We left off with what are the challenges of taking an open source project like Istio and deploying that into your environment and doing that successfully is not as straightforward as it sounds. So we built the Glue platform. The slide's a little busy. It's not intended to consume all the details right now. I'll step through it in a little bit. But we built the Glue platform knowing that if we're going to solve application networking and do it in an enterprise environment, we need to cover these areas. Because application has the word networking in it, so obviously we have to pay attention to the networking components, the lower layer, the CNI. So down, let's see, does that work? Right in this area. And then on top of that, we need to solve the application part, right? The layer 7, where the applications are actually communicating and sending requests and messages between each other. And then lastly, we need to solve how does traffic come into a system. Think of that as maybe it's a cluster. How does traffic come into a Kubernetes cluster? Or maybe it's a set of clusters in a particular line of business. Or maybe it's in a set of clusters in a public cloud. So how do we secure, monitor, and control the traffic as it's coming into these different boundaries? Off to the right-hand side, you can see some of the complementary pieces. So when you were deploying and talking about APIs, we need a way to discover and catalog and document these APIs. So we've built a portal that ties into all of this. I mentioned in the previous section, how can we expose these APIs and the data that they have in aggregate based on a GraphQL query. And then lastly, this is something that we see is very common in our enterprise use cases, which is, hey, you have all this stuff, it's great, solves 90% of what we need. We need to be backward compatible with what we already have. And that last 10%, you're not going to be able to do. We need to do. So we need some way to extend and customize the behavior of the networking policies. So we adopted probably a couple of years ago now WebAssembly as an approach to writing custom extensions to the networking behavior. We'll start in the middle. Just like we started the previous section with Istio, we're going to start in the middle here and talk about Gloo Mesh. So Gloo Mesh is based on Istio. So Istio is fundamentally at its core. And at Solo, what we do is we provide, first of all, we have builds of Istio ourselves. Since we provide enterprise break-fix support based on SLAs, we need to be able to patch something real quick and get you a build and remediate and solve any issues that are running in production. So we have our own builds. They are drop-in replacement for what the community does. We don't fork Istio. We don't add special sauce to Istio itself and try to lock you into our versions. They are drop-in replacement, like I said, for the community. Now, where things might diverge is where the community no longer supports a particular version. So the community will support so the current version of Istio and the previous version of Istio, plus a 4-week window after that. So about N-1 and 4 weeks-ish. It ends up being about 6 months. We support our builds from a lot longer, N-4, so the current version and the previous 4, which is approximately enough for our large enterprise customers to be able to upgrade and plan and prepare for managing a system like this at a more reasonable time. So like I said, we do offer SLAs and all that stuff around our builds. But so Istio is the core of Gloo Mesh. Brian mentioned our contributorship to the Istio project, our leadership on the project. And actually, this is a pretty important point. If we come over here and we go Istio community, go to the Istio community GitHub, should be able to see this. There are two main bodies in the Istio community that drive the direction, the technical direction, and the project itself. The first is the Technical Oversight Committee. So the TOC, Technical Oversight Committee, is in charge of the technical direction of the project, makes decisions and plans for future features, or what's going to happen. You can see here that the makeup, there's 6 folks on the TOC, 2 from Google, 2 from Solo, 1 from IBM, and 1 from Aviatrix. All right, so we are on 1/3 of the TOC. The steering committee, which more oversees the health of the project, how many contributors are contributing, and the diversity of the contributors, and putting on things like IstioCon, which we'll have at KubeCon EU, and so on. Also, a large group, and we have representation on that group as well. So we are firmly in the leadership, and very involved in the community, and we've built a team of experts at Solo. Brian mentioned 180 or so people. And so this is our focus. This is what we do, is we build and work on service mesh technology, work with those customers, and help them to be successful adopting this technology. Now, the interesting bits start to happen when you look at deploying in an enterprise across multiple clusters. You start to see things like, well, these are not all uniformly the same cluster. Like I said, some might be OpenShift, some might be EKS, some might be Rancher, or whatever. And then you find, well, these are not even all the same versions of Istio that are being deployed at times in these various clusters. And then we see that there's going to be cross-cluster communication that we need to, services communicating with each other. Either they've been deployed across clusters, or they need to fail over across clusters. We need some way to reconcile that, or to manage that. Certainly with security policies, with traffic routing policies, failover policies. Trying to manage that across multiple clusters with the low-level Istio API becomes fairly difficult. And so we've built a component that lives around Istio, or alongside Istio, that you can think of as a control plane of the Istio control planes. So that's the simplest way to describe what that is. Now, we need traffic to come into a system like this. Istio does, out of the box, have something called Istio Ingress Gateway. Istio Ingress Gateway is just a vanilla Envoy proxy, which itself is very powerful. But most people, when they want traffic coming in, they need it secured, and they need various options for security. Things like OIDC, things like API keys, things like they want to tie in with OPA, Open Policy Agent, or they have an LDAP registry and they need to tie in with LDAP. They need web application firewalling and request and response transformation, all this stuff that Istio doesn't have and Envoy doesn't have. So like I mentioned, there's a layer in our solution that specifically solves these API gateway use cases. And this gateway is built on top of Istio. So it uses the same Istio proxy and the same Istio control plane. So it is really the only native Istio API gateway. And for those folks that are looking to adopt a service mesh, having that real tight integration makes a lot of sense, because now you have one way of describing your application networking policies. Yes.
I got a question. So, just without Solo, right? Like, and if you're just using Istio, the ability to implement multi-cluster is there, right? It's just kind of a pain in the butt to get up and running. I'm assuming that's where Solo is kind of coming into play to abstract that, make it a little bit easier on the customer. Right.
So making it easier is a really big part of that.
Yeah.
Doing it the right way is also another part of that, because like, so for example, if you go to the Istio docs right now and you look at multi-cluster, you're going to find 4 different ways of doing multi-cluster. And then you say, all right, well, I'm going to pick this one because that seems to be good. And like, so there's one of the ways that you can deploy is called Istio multi-primary, I think is what it's called, where you basically have a control plane in each cluster. And if you go through those docs, we've built that model and the explanation of the docs and the step-by-step guide there to be as user-friendly as possible, right? Now, when you're doing multi-cluster, doesn't mean it's going to be easy. It's just we try to focus on user experience on that. But if you look at what it advises you to do, it says, hey, for this cluster here, create a secret that basically gives Kubernetes API access to this cluster here, create another secret that gives it access to this cluster here, another secret for this cluster, and all of the clusters, right? And do that for every other cluster in reverse. Now, when we pitched that to one of our financial institutions, they said, hell no, that's not going to work. So part of it is, yes, how do we make it easier to implement the policies, the multi-cluster support, failover, all that stuff? But the also part is, how do we do it the right way, and we do it the way that a security conscious organization would care about. So, for example, the way we implemented this is we install an agent into this cluster. This agent communicates with mutual TLS over to the management plane and says, hey, I'm cluster whatever 10. The management plane will say, okay, you're cluster 10, you need to have this configuration based on the security policies that we've set up. And then the agent takes that and applies it to the Kube API. We don't do any direct Kubernetes API remote invocations.
Got it. Okay, makes sense. Yeah, I think that's the ease of use is definitely a big piece, because whenever I'm talking to customers and we're talking about implementing service mesh, we're always either talking about Istio or Linkerd, and the question always comes up of, what's it going to look like later? How can we manage it? A lot of people go the Linkerd route because it's easier to get up and running versus, the Istio and stuff. So totally makes sense. Yeah.
Yeah. Any other comments or thoughts or people behind me? No, all good. All right. Like I mentioned the developer portal. It's a way to catalog the APIs, to expose the APIs, sometimes mash up the APIs, document the APIs, and all that stuff. That's in a fleet of services like this. So this developer portal is interesting, not because developer portals normally aren't that interesting, but why this one's interesting is that everything we've built at Solo is driven by declarative configuration. So if you're thinking Kubernetes, custom resources, right? That means you can tie all of these policies, security, access control, failover, resilience, all that stuff, including the developer portal attributes, into Git. So now you have a Git-centric way of auditing and controlling changes and deploying, right? In traditional developer portals, you log into a UI, you start pointing and clicking and saying that it's got to be this, there's the policies. If the developer portal goes away, or the database for that developer portal goes away, you're stuck. That was all there. Everything that we've built at Solo is driven through declarative configuration and can be brought back right up in a different cluster or whatever if there are failures. Changes are tracked and audited using Git and so on. I mentioned GraphQL as a way to expose, and I'll go into a little bit more detail about what that looks like. The last piece here is, did it not come up? There is the, all right, so we can control traffic coming in. We can control how we expose data. Maybe it's OpenAPI spec, gRPC, GraphQL, whatever. We can control the traffic policies between the services in a single cluster or across clusters, across clouds. We can manage that from a central location, but we can also tie in with the lower layers in the network as well. Because you can specify a policy that, I don't know, account service cannot talk to the order service for whatever reason. I will specify that policy at the service mesh layer. But let's say the orders service team forgets to deploy the sidecar, right? Now you just worked around one of your layers of security. So you need to have and be thinking about security in general, but certainly in this case as a layered approach, a defense in depth approach, and tying things in closer with the CNI, using technology like eBPF to get tighter integration with that is what we've built into our product as well. Yeah.
Question. Just referring to eBPF and Cilium, for example. So let's say I'm just bootstrapping a raw Kubernetes cluster with kubeadm, for example. When I deploy that, I'm still deploying kubeproxy. But let's say I don't want to use kubeproxy and I want to go straight with eBPF, remove the need for IP tables. Would I manage that in Solo, or would I still manage that at the cluster level?
You would manage that in the cluster level.
Cluster level. Okay, thank you.
Yep. Yeah, I'll go into a little bit more detail about where
Cool.
we fit in.
Thank you.
Okay, so Gloo Mesh it starts with Istio. Istio is the core. We have to have enterprise runnable and supportable builds. So Istio is the core. We have a central management system that we can use to drive the behavior of the mesh. That enables some interesting things, like I'll talk about in a second. When people adopt the technology, people don't want Istio. What they want is resilience. They want zero trust, and they want things like failover, high availability, and so on. We make that a lot easier to describe and to implement. When you expose Istio, when you expose these capabilities out to a team of developers, you have to be careful. You can't just say, "Hey, go use the Istio API." Istio API is pretty expressive, and there's a lot of power there. And you might not want to give all that to the developers. So what we've done in Gloo Mesh is we've built a multi-tenant, higher level API that you expose that to the developers, and that then will eventually get translated into a lower level Istio object. Things like managing the life cycle of Istio, especially across multiple clusters, especially multiple different types of clusters, different versions of Istio. That becomes pretty difficult to do, but we've automated away a lot of the difficult pieces there. We've built a system that allows you to integrate with your observability system so that you can do this across clusters. You can get a unified dashboard, a unified view over the traffic in the multiple clusters, whether it's on-prem or public cloud. So we've built a lot of tools to help you integrate with that. And then lastly, tying in with PKI, doing things like signing cert rotation, or even root certificate rotation, specifying cross-cluster and cross-boundary security policies. A lot of that stuff is pretty tricky in Istio, easy to get wrong. So we've solved and made that a lot easier. I'll give you an example. If you deploy Istio across multiple clusters, you can do this. Absolutely, you can do this. I mean, Istio is the foundational piece, and that's what we drive with that Gloo Mesh management plane. But what you'll find is that when you deploy Istio across multiple clusters, the policies that it requires to configure Istio are likely not going to be exactly the same on every cluster, especially if you have different services on these clusters. So when account service is talking to user service in this example, and it fails over, it probably just can't fail over to anything. Probably there's some rules about how it fails over. And there might be security properties around or compliance reasons why maybe services in the public cloud cannot fail back to an on-prem service. Right, so we run into a lot of the nuances of the configuration, the directionality of the traffic and the policies that you can't just say, well, here's the policy for service A, use Argo CD or Flux or something and just go spray that across 100 clusters, because each one of those clusters, there's some nuance again to the configuration. In Istio, describing behaviors like this, you've got to use the Istio API, the virtual service API, destination rules, sidecar resource, the service entries and so on, and managing the sheer number of objects, knowing that there's some low-level nuance and directionality to those objects, that gets very tricky. And like I said, you can use, GitOps is a great pattern, multi-cluster, all that stuff. There's some established things for when those clusters, are either exactly the same or the directionality is understood, but somebody has to understand it somewhere. And so this gets pretty tricky, easy to mess up. And when you're talking about security, easy to, mishandle. And so that's why that's part of the reason why we built that management plane, is to manage multiple clusters, understand what is the intent of the security policy or the traffic routing policies or failover policies, et cetera, and expose an API that understands multiple clusters and understands the intent of the user and how they want to configure the mesh. And so this API is a little higher level API that ends up getting translated down into the correct Istio APIs and put on the right clusters. Does that make sense? The big reconciliation loop. It's watching the clusters. It's doing global service discovery. It's listening for policy changes, and it's translating that down and pushing it out to the so it's the control plane for the Istio control planes in each of their respective clusters. There's a really important concept that we built into this API called the workspace, which is basically a way of carving up a cluster or set of clusters based on namespace. So you can say namespace 1 and 2 across these 3 clusters belong to team foo. Right? And you can say namespace 3, 4, and 5 across clusters 6, 7, and 8, they belong to team bar, right? So we can have a multi-cluster view and constrain a tenant to specific namespaces and the services that live in those namespaces and the policies that they can write, the networking policies that they can write about those applications or those services. And again, you might see me mention this a few times because this is pretty core to the way we see our enterprise customers operating, and we suggest that they operate, which is through a GitOps-based workflow. Stay away from proprietary UIs, custom databases, custom role-based access control to those UIs. Those just create more silos. Integrate into the rest of the workflows that you've set up for your platform. Will we end up seeing people use the lifecycle management, which is basically an Istio install and upgrade controller? What we see people using this is basically offering Istio as a service almost to their internal platform users, and being able to control and manage the lifecycle and installation of Istio.
So what comes first? Do you add the sidecar and discover what the running services are in the pod and then write policy around it? Do you pre-write policy and then apply that against workloads? I mean, how do you approach kind of...
So the question is, how do people adopt this? Do you write the policies first and then deploy the sidecars, or do you deploy the sidecars and then the policies? What I'll say is there's 2 main ways that people start. One is they don't use any sidecars and they deploy gateway, right? Because that's a fairly understood pattern. They can start to get the benefits of controlling the traffic just through the edge gateway. The second approach is They deploy the sidecars because the top, I think by far, the top use case for how people start with a service mesh is security. They want mutual TLS and encrypted traffic between services. So what they'll typically do is they start by deploying sidecar in a set of applications and just try to take advantage of the automatic mutual TLS that they get. And then start to branch out toward, well, maybe we'll write a retry policy, or maybe we'll write a traffic controlling policy. But it's usually they're deploying the gateway or the proxies, the sidecars first, and then experimenting with how to get the behavior into the cluster. So this is a dashboard that shows that we have two different clusters, cluster 1 and cluster 2. They are running in US West and US East. They're actually running as kind clusters, but for illustration, it's different regions, different clusters. And we've already just discovered a few things. One, what version of Kubernetes they're on, what version of Solo that they're on, and in this case, what version of, or what CNI they're using and what version of that CNI. I do want to point out that although we do have a UI here, and we're able to take a look at what's running on these clusters, this is a read-only UI. This is a current reflection of what's happening in the set of clusters at that point. Like I said, use GitOps to make changes, not point-and-click siloed UIs. We also have the application itself. So it's fairly, if you've seen Istio, I'm not trying to stray too much from the demo applications that they use, but if I refresh a few times, we see we get a couple different versions of the book reviews service. Either one with stars, black stars, or no stars. But we'll notice that the Istio book info demo also has one with red stars, but we don't see that yet. If I come to my terminal here real quick, actually, and show you, I think it's this one. And in the bottom left hand, can you see that okay? Kind of.
So yeah, so the demo application he's showing, it's called Book Info. It's a number of microservices. So for example, when he's kind of refreshing the screen there, what you're seeing is like the reviews is its own microservice. The thing that tells you about the book is its own. Think of it as like an inventory application. And one of the things that he's showing as he's doing some of those refreshes is, and he'll show it as we go along, is let's suppose we want to make a change to one of those microservices. Do I do it to the point that was asked before? Do I do that as sort of a big bang? Do I do it for a percentage of traffic? He's going to kind of walk you through what some of the toggles behind the scenes look like in order to change what the user experience looks like.
So you can see on the bottom left, we have the detail service, the rating service, like Brian was just describing, and then reviews V1 and V2. So that's in cluster 1. In cluster 2, we have reviews V1, V2, and V3. But when I'm refreshing traffic, or I'm refreshing the browser here, I'm only seeing reviews V1 and V2. The traffic is actually coming in, and it is going to cluster 1. Where's this? Here's the dummy. You can see it here. Traffic's coming in. It's going to cluster 1. Front ends are calling the back ends, and you're getting a response. But what we're going to see here is I've configured. So Istio is running here. Gloo Mesh is managing those Istios because we can see them here in the Gloo Mesh screen. I've configured Gloo Mesh to apply a failover policy for communication to the reviews service. And actually, if I come into Git and take a look at my configurations, so if we take a look at, I think it is here, here's our failover policy. So this is basically saying I want failover between calls to the book info front ends, and when I apply that using Argo CD in this case, and we can see everything is all synced up, ready to go. Here's our failover policy. That if I take down the product page in cluster 1, Istio should figure out all the right things it needs to do to fail over to cluster 2. All right, so if I come back here, go to cluster 1, find the front end, find the deployment, and I'm going to scale this down. It's at 1 right now, but I'll scale it down to 0. So now there should be no more product page in cluster 1. But Istio will detect that that doesn't exist anymore. And cross fingers, we should get a response. Number 1, we did. And eventually, if I refresh enough times, we should see a red, the black stars, we should see red star. So now we know traffic is going over to cluster 2. Now, if you take a look at how you would describe this in Istio, Istio's config, you need things like service entry, things like virtual service. Here, let me just see if I can do this. And context in cluster 1, get service entry. So in this case, there's only one, but imagine a lot of different services. You're going to have a lot of different service entries and virtual services that you're going to have to manage. And when traffic directionality is important, you're going to have to manage the differences yourself somehow, either in somebody's head or written down in a spreadsheet or whatever. But so the management plane is able to take a policy like failover. Here's our failover policy. Here's a rate limiting policy, and which is a higher level policy than what Istio has, and then translate that down and push it down to the correct clusters.
It's basically taking all of these best practices and individual policies and looking at them as a whole and applying everything, or like figuring out the best route, figuring out the best.
It's taking so if I take a rate limit policy, for example, or the failover policy, those policies will be considered in terms of a tenant, and the tenant here is the workspace. So if I specify a policy, it's not for every cluster, every service, everything across the global universe here. I'm going to apply a rate limiting policy for a workspace, and the workspace might have 5 services in it. Maybe it's that book info application that I had. And I can control and manage the networking policy for that workspace, independent of the other ones, and it won't step on or conflict with any of the other policies that might be written, because they're going to be constrained to their own names or a workspace. Now, within a workspace, I can also export certain policies, or I can import certain policies. So I can be very explicit about when there is configuration that needs to cross tenants, what exactly that is. And then I can do things like, so for example, maybe I have an operations team or an API gateway team, let's say API gateway team, and they've deployed a gateway, and they want to allow the book info team to expose their apps on that gateway. And they don't want to control the routing, all that stuff. They want the book info team to control that. So what they do is they make the gateway, so they can export certain properties to the gateway that allows the book info team then to import that and then write their policies about how traffic should be treated for the book info without touching or talking to the gateway team for things like routing. But you can say, hey, the book info team has no business managing TLS certs on the gateway or other security properties, so don't expose that to the book info team.
Is there ever a time that there would be implemented a global policy versus a granular one? Okay.
Yeah, and you can do that too.
Okay.
Yep.